Hey, Miss Nguyen here with our notes for proportional versus non-proportional relationships. Right? It's kind of a shame we're doing this online because originally in school when we did this, we had a really nice, foldable with each page a different color, and it was super cool, but, we're going to do the best we can with these. Okay? So we're on the first page, right? Proportional relationships are special because the distance between each pair of numbers is always the same. They're equal. Okay, so we've already talked about proportional relationships before when we were doing direct variation. So that's what makes them special. Like if you are working a kind of minimum wage part-time job and you get paid $10 an hour, you're always going to get paid $10 an hour. So every hour you get $10. That's proportional. Remember, if you are working as like a waiter, waiters sometimes make only $3 an hour, but then they get tips, and every hour the amount of tips they get is different. And so that would be a non-proportional relationship. So a proportional relationship, the distance between each point, each pair of points on the line is always going to be the same. That's what makes it proportional, right? And so we're going to go through all the different situations that we can tell whether or not a relationship is proportional or non-proportional, right? So the first thing we're going to look at is tables. So here's some examples. So remember, when we were doing direct variation, to figure out the constant of proportionality, k, we had to set up a proportion of y over x, right? Well, now that we're moving into non-proportional relationships as well, instead of using k, we're now going to use the m constant. So m equals y over x. And so this is what we're going to be moving forward. This is what we're using, right? So what we want to do in a table is we want to take y over x for each of these entries. Each entry in this table is a point. A table is our way to show, like, these are a bunch of different points in a line. This is the x coordinate, this is the y coordinate. Here's another x coordinate, here's another y coordinate. So we have 4 points in this table. And so what we want to do is find the m of each of these points in the table. And if the m is the same for all 4 of them, then that means that this table is going to be proportional. If any of the numbers are different, then it's going to be non-proportional. So let's take this here. Okay, it has to be y over x. This is our y column, this is our x column. So for this first point, we're going to do 4 divided by 2. 4 divided by 2 is 2. All right, let's do the next point. We have 12 divided by 3. 12 divided by 3 is 4. So we can already see that these two don't match, and so this is going to be non-proportional. And I just wrote this one out, but from now on, whenever it's proportional, we'll write a letter P, and whenever it's non-proportional, we'll write NP. Now just let's save both of our wrists. Okay? As soon as you have one that doesn't match, this m is different from this m, then you already know the whole table is going to be non-proportional. For it to be proportional, all 4 of them have to match. All right, so let's look at this one. Same thing, y over x, y divided by x, y over x, y over x, okay? Y divided by x. So our first point, our y is 64, our x is 8, so we're going to do 64 divided by 8. 64 divided by 8 is 8. Next one is 36 divided by 6. 36 divided by 6 is 6. Uh-oh. We have another mismatch. This is also non-proportional. Right? Now we have 2 tables that are gasp, these two tables are horizontal. Now everything is completely different. Just kidding, it's not. It's exactly the same. So now you just have to make sure, be careful, now our y's are here and our x's are on the top. So if we're going to do our y over x for each one, just make sure you put the right numbers in the right places. So for our first point, we have y is 24, x is negative 2. So if we do 24 divided by negative 2, we get negative 12. Okay? Next point, y is 60, x is negative 5, so we'll do 60 divided by negative 5. And if you don't know this one off the top of your head, this is one you might want to type into your calculator. But since I know what it is, it's going to be negative 12. So far so good, but for it to be proportional, all of them have to match. So for proportional, we have to keep going. Or just, you want to keep going until you find one that doesn't match or until you've done all 4 points, right? So next one, 84 divided by negative 7, it's negative 12. Last one, y is negative 108, x is 9, so we have negative 108 divided by 9, shock and awe, negative 12. So all 4 of these m's, because remember that's what we've been calculating is m, all 4 of these m's are negative 12, so this one is finally proportional. Last table, y over x, so negative 9 divided by negative 3, that's 3. Negative 5 divided by negative 1, that's 5. Oops. It's not the same m, so this is non-proportional. Those are nice because you can stop and not have to do everything, you know. Alright, so that's basically it. This is the kind of math, well, it for tables. We're not done, sorry. This is the kind of math that's easy to do but kind of hard to remember how to do. So that's the tricky part, but all we really have to do is divide and see, okay, did our numbers match up? If they matched up, they're all the same, proportional. If they didn't, then it's non-proportional. Okay, so let's fill in this little text on the bottom. For proportional relationships, we use m to represent the constant slope. So we're going to write the equation as y equals mx. Now we've also used k before to represent the same thing, but as we start doing more and more of these equations and graphs, you're going to see m come up more often, so we're just going to go ahead and start setting those habits early. Okay? Alright. Now at this point, this part is independent practice, so take a moment and do these. I will show you the answers so you can check your work, but remember when I'm checking your notes, I need to see work. So if all you do is copy down the answers I'm about to give you, then you're not going to get full credit on your notebook check. Okay? This first one, hopefully you paused and you worked through it. This first one is non-proportional. The second one is proportional. This third one is proportional. This fourth one here is proportional. And then this one here is non-proportional. So again, you need to show your work, but at least this way you can check your answers and make sure you're doing it right. Alright, let's move on to the next page. This is the trickiest one, okay? The equations can be pretty tricky. Okay. Proportional equations are written in the form y equals mx. This is m times x. Remember when you have two variables or just, two numbers next to each other, like one is in parentheses, one isn't, or when you have variables like this, you don't need the parentheses. That means you're multiplying them together. So for proportional relationships, proportional equations, multiplication is the only operation allowed. So we can only have multiplication. If we have anything being added or subtracted, then we're no good. That's not going to work. Sometimes the multiplication may be disguised or hiding. And I'll show you what that means. So sometimes you might have to rearrange your equation a little bit to see if there is an m. Because what you're looking for is you want an equation that you can rewrite as y equals m, and m can be any number, right? Y equals m times x. If there's anything else, like mx plus 10 or something, then it's non-proportional. So let's look at these examples. Zoom in a little. Okay, so we're on the left here. So we have y equals 1/2 x. This is pretty standard. This here is our m. So we could rewrite this as y equals mx. Our m is 1/2. So this is proportional. You see how there's nothing else written over here, no plus 5 or minus 2 or anything like that. So even though m is a fraction, this is proportional. It's okay if m is a fraction. Number 2, y equals 1 divided by x. So this is 1 over x, that's 1 divided by x. This is not multiplication, so this is non-proportional. Okay, now 2 is different from 3. You can see in number 2, x is in the denominator, it's on the bottom. Number 3, x is in the numerator, that means it's on the top. So number 3 is actually proportional. Here's the reason why. This is one of those ones with a hidden fraction. Remember, when you have a variable that's by itself like this, there's actually a hidden number 1 in front of it, because this is a 1x. Mathematicians, we don't write the 1 because you see the x right here, you see 1x. You can count them, there's 1x here. So it's implied that there's a 1 here. We don't have to write it every time. So whenever you have a fraction and x is on top, there's a hidden fraction, the hidden m. What you want to do is you want to draw a box around all the numbers except x. You want to cut x out. And what you have left, this fraction 1 divided by 4, that is our m. Okay, so you want to draw this little box to cut x out of the fraction, and what you have left over is m. Now, this only works when x is on the top. You can't do that here. It's not going to work. So let's write up here. X on top is proportional. X on top is proportional. X on bottom is non-proportional. We cannot have x on the bottom of a fraction, so it's like 4 fractions. X on top is proportional. X on bottom, non-proportional. Now that's assuming there isn't anything else. Like if this was x over 4 plus 2, that would still be non-proportional. I'm talking about when you only have this fraction and nothing else. If x is on the top, it's going to be proportional, so you just need to figure out what the fraction is. When x is on the bottom, that's when it's non-proportional. And remember, when x is by itself, there's a hidden 1 there. So this is 1/4. If you had, x over 5, then m would be 1/5. If you had x over 3, then m is 1/3, and so on and so forth. Okay? Let's move on. Number 4, y equals x squared. This is not multiplication, this is an exponent, so this is non-proportional. So no squaring of x. Okay? You could have m be like 3 squared or something like that's fine. M can be anything. M can be negative, m can be a fraction, m can be a decimal. That's fine, but we can't do anything to x except multiply. You can't divide by x, you can't add, stuff to x, can't square x, that's bad. Number 5, this is a textbook definition of non-proportional because of this. You have 2x, this is the m, our m is 2, but you're adding 1 to it. This is addition. Cannot have that, so this is non-proportional. Number 6. Okay, this might be a little tricky. This is proportional, because remember how the x, I told you when x is by itself, there's a hidden 1. That's the hidden 1 there. Our m is -1. And there's nothing else being added or subtracted, so this is proportional. Almost done, 3 left. Number 7, y is the square root of x. This is non-proportional. We cannot take the square root of x, that's not multiplication. Cannot do the square root of x. You can do the square root of something else, like m could be the square root of 2, that's fine, but you cannot take the square root of x because that's not multiplying. We can only multiply stuff by x. We cannot add to x, no squaring x, no dividing by x, no square root of x. Like, the only thing we can do to x is multiply. Number 8, this is a nice simple one. Here's our m right here. Oops. That's our m. Our m is 5. There's nothing else being added or subtracted. This is proportional. Last but not least, this one is really similar to number 5. You see this little extra bit here? This is subtraction. We don't want that. This makes it non-proportional. We can only multiply by x. We can't subtract from it. Okay? So over here are all independent practice. So I'm going to do the same thing where I will give you the answers. So pause here, try it on your own, and then check your answers, but I expect to see work, okay? On the ones that are proportional, I need to know what m is. And I'm not going to tell you that in this answer. I'm only going to tell you if it's proportional or non-proportional. It's up to you to find m. Alright, did you pause? You worked on it? Number 1, x is on the top here. This is proportional. Number 2, this is proportional. Number 3 is non-proportional. Number 4 is proportional. Number 5, non-proportional. Number 6, proportional. Number 7, non-proportional. Number 8, non-proportional. Number 9 is proportional. Number 10, here we go, x on top again, this is proportional. Number 11, non-proportional. And number 12 is proportional. Okay, so if you got any of these wrong, double check. And use these to guide you. If you see one that's similar to one on the left, maybe use that to help you figure out. And if you're still stuck, let me know, ask me, and I'll be happy to explain. So the equations part is the most complicated, trying to figure out if it's proportional or non-proportional. But those are some rules that you can help, it will help. You know, multiplication only, no squaring, no square roots, no adding, no subtracting. And this is 2x. You can have square roots of other numbers, that's fine. Like m can be a square root. You cannot take the square root of x. You cannot square x. You cannot divide by x. That's why we don't want x on the bottom. Okay? We only want multiplication for x. Something, so your equation should be y equals something times x. That's it. If there's anything else, then it's non-proportional. Alright, next we have graphs. Graphs of proportional relationships. Okay? So now we're going to look at the graphs to figure out if there's a pattern to graphs of proportional relationships versus non-proportional. Okay, so let's look at this first one. Our equation here is y equals 2x. So we're going to graph that. How? Well, first we need to figure out what the points of this line are going to be. So to do that, we're going to use this little table. Now remember, x is the independent variable. So y changes based on what x is. So that means that for x, we can basically choose anything. Except right here, you see we have this graph here. So when we're choosing x's, we need to make sure that we're choosing x's that are on the graph. Like, 5 is here, so we could choose 5 for x, -3 for x, that's fine. But we can't choose like 10 or 20 because that's not on the graph. There's no way of us plotting that point. It's not here. So when you're picking points to plot, just make sure that your graph can accommodate those points. So let's just pick a couple of numbers at random. Let's do, 0, 2, and -2, right? Something like that. So when we have our x's, to figure out what our y is, we're going to use this equation that they gave us. It says that y equals 2x. So whatever x is, we multiply it by 2, and that will tell us what y is at that point. So our process is y equals 2 times 0 for this first point. Remember, when you put this one number in parentheses and there's another number outside, these two numbers are being multiplied together. So this is our way of representing 2 times 0. 2 times 0 is 0, right? So that means this point is 0, 0. For coordinate points, x comes first, y is the second number. So our x is 0, our y is 0, so our point is 0, 0. Our next point, same process, different number. Y equals 2 times 2. So you see, all we do is we take this number here that we have for x and we plug it into the equation. Like, this is x, so we replace the x in the equation with the number we chose for x. So y equals 2 times 2. 2 times 2 is 4. So our next point is 2, 4. X is 2, y is 4. Last one, and the reason why I chose a negative is to make sure that when we're plotting our line, we have some points over here. It'll just make it easier to connect the dots, and you'll see in a second. So same process, y equals 2 times -2. 2 times -2 is -4. So our point is -2, -4, right? So now that we have all 3 points, we are going to plot them onto this graph. That's our next step. Okay. Our first point is 0, 0. So it's the point where x is 0 and y is 0. That is right smack dab in the middle. We call this the origin, by the way, and I'll get to that in a little bit. But so here's our first point. This is 0, 0. Our next point is 2, 4. So our x is 2. So let's find, here's 2 on the x-axis. This is labeled. Our x-axis goes side to side. Our y-axis goes up and down. So here's 2 on the x-axis, and our y is supposed to be 4. So if this is 2, and then this is 4, this is where our point should be. And if you're not used to plotting points, you can take your time, draw these lines, and that'll help make it easier for you to pinpoint exactly where that point is supposed to be. And then if you want to neaten it up, you can always erase the lines after, like that. So here's our point, 2, 4. Remember, x is first, so 2 on the x-axis, 4 on the y-axis. Last point, we have -2, -4, so same thing. Here's -2 on the x-axis, and then if we want to draw a line like this, here's -4 on the y-axis. So this point here where they meet is our point. And then after you're done, you can always erase the 2 lines like that. So now we have our 3 points, and we can connect them with a line. Cami has this cool line tool here. I want it to be the same color, so let's do it like that. When you're using the line tool, just so you have it at the same angle, you want to pick one of your points. I like to go from the left to right, so I'll pick this point here. And then you click and drag, and make sure that your line goes through both of those other points. And you want your line to go through the whole graph, and so I usually make it a little bit longer than it has to be, and then afterwards I can move it like that. So now we have our line for this proportional relationship. Okay, now let's go ahead and do the next one, and then we'll compare and contrast and talk about them after. Let's do the next line. Same process. This time our equation is y equals x plus 1. And you hopefully already know from the equation that this is going to be non-proportional because of the plus 1, but we're going to go ahead and do this so we can see what the graph looks like. So again, we're going to choose random points. I'm going to choose different ones just to do something a little different this time. So let's say 3, 1, and -4. Okay. So our process is pretty much the same, except this time our equation is different. So instead of multiplying them, we're going to be adding 1. So our y is going to be 1 plus whatever our x is. So for the first point, y equals, our x is 3, so 3 plus 1. 3 plus 1 is 4. Next one. Oh, sorry. So our point, x equals 3, so the first coordinate point, that's 3, 4. Remember, x comes first, so our x is 3, our y is 4, so that's our coordinate point. Next point, y equals 1 plus 1. 1 plus 1 is 2. So when x equals 1, y equals 2, so our point is 1, comma, 2. Just like that. And then maybe pause the video here for a second, see if you can get this on your own. Right? Y equals negative 4 plus 1, that is negative 3. X is negative 4, y is negative 3. Alright, so now we have our 3 points, and we're going to go ahead and plot them and make our line, same as before. So our first point is 3, 4, so 3 on the x-axis, 4 on the y-axis, so I'm going to do this. I know my line is not super straight, that's fine. I'm going to erase it anyway. What does Bob Ross call them? Happy accidents or something? It's fine. So y equals 4, x equals 3, so the point where those two lines meet is where our point is supposed to go. Then you can erase the lines after to neaten it up. So there's 3, 4. The next one is 1, 2. So x equals 1. Well, that's really not straight at all. And y equals 2. Here, right here. Last but not least, we have negative 4, negative 3. So here's negative 4. That's really bad. It's okay to make mistakes. See, I do them all the time. And then here's a negative 3 line. So here's our point. I'm going to erase these. There we go. Now we can use our line tool. Start here, go through. See, I like to make it extra long. Oops, that angle is a little bit off. See, I'm not going to be that picky, so if your angle is a little bit off, that's fine. I'm not the type of teacher that'll be like, oh no, your line is 2 pixels too far to the left, 30 points off. It's okay, it's not that serious. But it's still nice to get close if you can. There we go. Okay, so there's our line. Alright, now let's zoom out and look at these two lines together. Okay. The main difference you will notice between these two lines, hopefully, is that this first one passes through the origin. It goes through the middle. The origin is the very center of the graph. It passes through this middle point. This graph does not. It's very close, but you can see when x is 0 here, y is something else, almost 1. So it does not pass through the middle. And so that's what you can type here. Okay, line passes through the origin, 0, 0. This is proportional. Right? So this line, it passes through the origin, therefore it is proportional. The second one, the line does not pass through the origin, it is non-proportional. So when you're looking at a graph, that's what you're looking at. Does it go through the center? If it goes through the center, it is proportional. So the center being this little point, 0, 0. When x is 0 and when y is 0, that's the origin right there. If it does not pass through the center, does not pass through the origin, it is non-proportional. The other thing that's very equally important is that for a line to be proportional, it has to be a straight line. So graphs of proportional relationships must be straight lines, or must be a straight line, and go through the origin. Okay? So let's look at some examples here. Okay, so we've got a couple of graphs on this side. Let's look at this first one. You think this is proportional or non-proportional? Hopefully you said this is non-proportional because this is not a straight line, it's a V. It like bounces back up. See, this does not look like this graph over here. This is non-proportional. This one, let's look at this one. Is it a straight line? Yes, check. Does it pass through the origin? Yes, check. This is proportional. That's the only mental checklist. See, this is much easier than equations. Straight line, yes. Proportional, or sorry, straight line, yes. Pass through the origin, yes. Then it's proportional. Number 3. This is non-proportional. First of all, it's not even a straight line, it's a curve. See how it curves up, it's kind of rounded. And it doesn't pass all the way through the origin, it just kind of stops right there. So it's no on both counts. Number 4, this is proportional because this is an example of a graph that only has one quadrant. You see how the other ones have 4, but this one is just positive x's and positive y's. But if we were to extend it, it would keep going beyond this axis here. And you see this is the origin right here in the corner when x is 0 and y is 0. So it is a straight line and it passes through the origin. This is proportional. Okay, let's go here. This one, is it a straight line? Yes. Does it pass through the origin? No. Here's the origin. This is all the way, it goes down here. This is non-proportional. Last but not least, we have this here. Is it a straight line? Yes. Does it pass through the origin? No. Here's the origin right here. It did not, almost, very close. This does not pass through the origin, so this is a non-proportional graph. Okay? Alright, we're almost done. Last page. Sort of. Well, you'll see. So now we're still looking at equations, but we're looking at equations written as word problems. Okay? So things to remember. Make sure you use your keywords. And originally, before we had our keywords as almost like a separate notes page, but now, for convenience sake, if you scroll down to the last page, you'll see, oh, here's all the keywords. You don't even have to write them in. We already have them all for you. Okay? Now these 3 are very, very important. Per, each, and every. And I'll get back to that in a minute, but maybe circle, put a star. These are very, very important. That star looks okay. I'm not an art teacher, I'm a math teacher. Okay, so we'll come back to that, but these are very important. So you can cross this part out, or, you know, James from one of my classes said that you could just fill this blank with next. So make sure you use your keywords on the page next. It is what it is. Okay? If the word problem does not have this phrase, varies directly with. Okay, because remember when we did direct variation, there were those 2 key phrases that I told you guys to look out for. Is varies directly with and is directly proportional to. When you see those 2 phrases, that's a little red flag telling you, hey, this is a direct variation problem. If the word problem does not have that, you need to set up the problem to find m by doing y over x and then write the equation. Okay? So here are some examples. Priscilla is a wedding planner. She charges a $50 fee plus $100 per guest. So this is where annotating gets very important. And if you have your own preferred method, that's fine. If not, let's do what I do. I like to circle numbers and underline key words. So here's a number, $50, circle that. Here's another number, $100, circle that. Here's probably an important mathematical keyword, plus. This one is more self-explanatory. Yeah, we know what plus means. And here's another one, per. What does per tell us to do? Well, according to this handy-dandy chart, per means we're doing multiplication. Remember how I said per, each, and every are very important? It's because when we're writing these equations from word problems, when you see per, each, and every, it's telling you this is m. This is the number that's being multiplied by x. It's very important. So here it says $100 per guest, and this is multiplication. $100 per guest. So if we're writing our equation, remember it starts out with y equals 50 plus 100x, because this is 100 times x. That's what per means. So that's how we write this equation. Okay, and so you can see this is non-proportional because of this 50 plus here. We cannot add to x, so this would be non-proportional. Okay, let's look at the next one. Mrs. McKinney's class makes aprons to give to a local soup kitchen. Each apron requires 2 1/4 yards of fabric, and the cost of fabric per apron is $9. Okay, so each apron requires 2 1/4 yards of fabric, and the cost of fabric per apron is $9. So this equation, this word problem is written kind of funny because what equation you write kind of depends on what the problem would tell you. So we're missing some information here. Normally it would say something like, write an equation for the relationship between how many aprons there are and the yards of fabric required. Because if we were doing that, then our equation would be y equals 2 1/4 x. Right? Because it says each, and it says that each apron is 2 1/4 yards. So x would be how many aprons you want, and after whatever you get for y, that's telling you, okay, if you have this many aprons, this is how many yards of fabric you need. Or this problem could have told us write an equation for the relationship between the cost of the fabric and the number of aprons. That would be a different equation. That would be y equals 9x. So we see how we have this per here? Because x would be the number of aprons. 9 is telling, that's our rate of change. That's $9 for each apron. So once you multiply, like however many aprons there are, y is telling you this is going to be the total cost of fabric. So both of these are proportional because nothing else is getting added, but this is a little confusing in that it's a little relative, like it depends on which relationship we're writing an equation for, right? But either way, both of these would be proportional because nothing else is being added. Finally, we have a movie rental company charges a yearly membership fee of $18, and each movie rental is $1.50. This is another one that's a little bit vague, but I'm guessing what the problem is asking is, what is the relationship between, the number of movies you rent in a year and how much you're going to pay for movie rentals that year? Because you pay your annual fee, that's $18. So you pay $18, so y equals your $18 fee plus $1.50 for each movie that you rent. So x is the number of movies, y is your total cost. So if you rent, 10 movies in a year, you would multiply that by 150 and then add the 18 that you paid for your yearly membership. All right? So because of this is adding, so this is non-proportional. Okay. So now we have some more independent practice over here. Right, so I would like you to write equations for these and then tell me if it's proportional or non-proportional. I'm not going to do the equation for you because you need to learn those keywords, but I will give you the answer of whether it's proportional or non-proportional so you can kind of check your work. All right, number 1 is a proportional relationship. Number 2 is non-proportional. Number 3 is non-proportional. Number 4 is proportional. Number 5 is non-proportional. And number 6 is proportional. All right, and again, this last page, there's nothing to fill out. These are all just key words, and this will be important. I'll probably either re-upload these to future notes or just to make it easier so you don't have to keep coming back to this file. But these are ones that as we do more and more word problems this year, it's going to be very important for you to know this. And so we might do some activities like, digital flashcards and stuff for these. All right, that's about it for proportional and non-proportional relationships. I hope this was helpful for you. I will see you in class. Bye. Don't forget to do the assignment.